Before jumping onto the preparation strategy, let's first try to understand what is low-level design round, how to strengthen the concepts of low-level design as well as its application, how to prepare specifically for its interview. But then what makes solving LLD problems different from solving the usual DSA problem? Low-level design interviews can be quite daunting. Many students complain that despite practicing multiple problems, they aren't able to come up with a proper solution during the interview, as the problem statements are limitless, unlike DSA rounds where you know that certain algorithm-related problems will come. In LLD rounds, there's no sure-shot recipe as such which you can apply and solve every question. But not anymore, because I have devised a strategy for preparing for these interviews which will guarantee your success in these rounds no matter what problem the interviewer throws at you. So let's begin. Hi, I'm Shaktimani Tripathi, currently working as a SG2 at Amazon. Just to give some kind of assurance, I have cracked SG2 interviews of companies like Microsoft, Google, Amazon, Uber, Rippling, Atlassian, Swiggy, ShareChat, and lots of others. And I've received highly positive feedbacks in LLD rounds of each of them. So this is not going to be just another LLD roadmap video. I know what I'm doing. You can have your utmost faith on me. So let's get started. Before jumping onto the preparation strategy, let's first try to understand what is low-level design round. A low-level design round in an interview typically involves evaluating the candidate's ability to design and implement a software system at a detailed or component level. While high-level design focuses on the overall system architecture and how the components interact, low-level design focuses on the design and implementation of individual components. This can include designing algorithms, defining data structures, specifying interfaces between components, and sometimes even writing pseudocode or actual code. In other words, you will be asked to design and implement a functionality or a system that has multiple functionalities. From designing, you'll have to explain the whole step-by-step working of the functionality or system, what all components will be there and their corresponding role in making that functionality or system work, how all components may or may not interact with each other. Now from implementing, you'll have to implement the various classes and interfaces that will correspond to the components of the system and how they interact, and implement the various methods of each of those classes that will perform the desired tasks of the system or functionality so that it can function as a whole. Now let's jump into its preparation. Now for explaining its preparation, I will first break it into two parts. First is how to strengthen the concepts of low-level design as well as its application. And lastly, once the practice is done, how to prepare specifically for its interview. So let's jump into the first part, how to master low-level design concepts as well as its application. Let me tell you, low-level design is nothing but coding only. That is, you have to solve a problem by coding for it. But then what makes solving LLD problems different from solving the usual DSA problem? The DSA problems are majorly mathematical in nature. Also, they are very much, hypothetical, much like a maths word problem that we used to do in high school, if you remember. It may be tough to solve, but they mostly are fake scenarios created just for your mental exercise. On the other hand, low-level design problems aren't that much mathematical in nature. They mostly are problems related to a real-life situation, unlike a DSA problem, where you don't have to know what you're gonna practically achieve after solving it. For example, if someone asks you to code a data structure that will keep taking a stream of integers and at every instance tells what are the largest k integers processed till now, that becomes a DSA question. But if someone asks you to design a real-time leaderboard of a multiplayer shooting game in which the first page of leaderboard will show the top 10 highest scorers till any point of time, then it becomes a low-level design problem. The underlying principle as well as the working is same for both of it. It's just the way that it's asked is different. In both of them, you're going to implement a heap, just that in the latter one, its real-life use case as well as what it is accomplishing. Also, the implementation in the latter one should mimic production-ready code better than the former. Now that we have a brief idea about LLD, let's try to master it. Firstly, pick up a programming language and master its syntax. It's extremely important because how tough you find implementing LLD will depend a lot on which programming language you're gonna choose. I'd suggest you to pick any of these four languages: Java, Python, C++, and JavaScript. I preferred Python because I found it very easy. Also, I've worked on it in my previous companies, so most people use Java though, but I felt Python to be most comfortable. Secondly, I would suggest you to learn about the software design principles as they help you to make your code verbose and more readable. It's a very important aspect while implementing the low-level design. And try to write basic programs using them with your limited knowledge of the selected programming language. In my case, it was Python. So the design principles that you need to learn can be broken down into three categories. Category 1, dry, Yagni, Kiss, etc. Category 2, abstraction, extensibility, cohesion. Category 3, the solid principles, which are the most important ones. And also, before jumping into the category number 3, you need to first complete category number 1 and 2. The links for these resources I have added in the description, so you can check them out. Now I would suggest you to learn OOPS in depth. It might vary for every programming language, but the core concepts remain the same. That is inheritance, polymorphism, abstraction, encapsulation. Revise these and watch some videos on their applications. Also dive a little bit more in the OOPS concept specific to your language that you have selected. For example, if you have selected C++, you must know concepts like what are virtual functions and all. Or if you have selected Python, try figuring out like if multiple inheritance is possible in it or not. And similar intriguing questions like that. I'll suggest you to practice problems on OOPS concept as well. For example, try to solve basic OOPS problem that are mostly present in the exercise section of your programming language. That is, create a company class having employees in it with methods that return name of the company as well as employees with age greater than 30. And similar questions like that can be made to that particular problem state. I mean, you get it, right? Now, once this is also done, do learn and practice design patterns. So, what are design patterns? Design patterns are standard reusable solutions to common problems that occur in software design. These patterns aren't finished design or code that can be directly translated into an application. Instead, they represent a best practice or a suitable approach to solving a problem that can be used in multiple different situations. They are extremely helpful tool to make your code production ready, loosely coupled, and verbose. It is extremely important that you implement LLD questions keeping these patterns in check, because in production ready code these patterns are used a lot. Some famous design patterns are singleton pattern, factory pattern, prototype, abstraction, builder, adapter, decorator, observer, pub sub, chain of responsibility, and so on. Learn all of these and many more from YouTube videos or maybe the link that I've provided in the description that you can check. Now it's time to practice LLD questions, and believe me, you just need one course, which is Grokking Object-Oriented Design Interview course. This course is a beast altogether. I mean, you don't need anything else if you're going to solve it. And you can either buy it in $30 or you can just get it from the link that I've provided in the description, where it's completely uploaded. I'm not sure that it's the original version, but you can check it out. Believe me, the questions in this course are just enough. It might take 15 to 20 days for you to complete this course, even if you do one question per day. This course has explained what is the procedure to attempt a low-level design question in detail by enumerating multiple steps. And I would definitely recommend you to learn and practice each of the mentioned steps in depth. Please don't miss any step, because they are highly important, because this course entirely covers like all the things related to UML, class diagrams, use case diagrams, sequence diagrams, activity diagrams, and all. Everything in this course from head to toe is important. So please, revise it thoroughly. When you attempt a particular problem in this given course, firstly, just read the problem statement and try to implement the complete solution by your own self without looking. But this helps to build your mental muscle in this particular context. And once that is done, take the solution they have given and try to understand it in depth. Take as much time as you need, because there are only 15 to 20 problems in this course. So this course is not too big, so you have enough time in your hand. And then again, try to implement the whole solution, including UML as well as the other diagrams, without looking, and then only cross-verify each and everything. This strategy of revising and learning simultaneously has worked wonders for me, and that's why I'm recommending to you. And now, once all of this is done, you are ready to attempt any LLD problem, in my opinion. Like, the only thing that is left is how to excel on the interview day, because interview is not just about implementing what is given to you like a robot. You have to cross communicate, ask questions, and explain the solution as well. So let's see how to take care of all of that. So generally in this interview, the interviewer might ask you questions of LLD in two different ways. Either they'll just ask you to implement an API that performs some functionality, or they'll just ask you in standard fashion, that is, design a XYZ system. In either case, the interviewer will always give you a vague problem statement, and it's your job to sync with him regarding the problem clarity. Also, interviewer will mostly judge you for how you basically enumerate the various system requirements from the vague problem statement that has been presented to you. So keep that in mind. Now, for the first type of problem statement, it is usually multi-leveled in terms of difficulty. The interviewer will level it up by adding more and more difficulty to the problem once you start answering the current part. So you might not have to approach it the way you approach a typical LLD problem. For example, they might ask you to design an API that basically, when given a set of integers as input, returns their sum as output. So it feels simple, right? But when you answer it, they might ask you to make this API flexible enough to return output of any operation applied on these integers. For example, mean, median, mode, multiplication, etc. Then they might even ask you to segregate the output in two groups. First one containing output for integers present in even indices, and the output present for the integers on the odd indices, and so on. The thing is, in such problems, you might not be required to make UML or class diagrams, as it's not a system, as you see mostly in the typical LLD problems. These questions are mostly asked to see how well you can make the code verbose, flexible, readable, and apply design patterns accordingly. Basically testing your overall OOPS knowledge. So don't code it like a competitive programming problem, even though it seems one. So the only advice that I can give you for such question is to listen what the interviewer is asking and implement exactly that, not more, not less. And once they add more to the problem, then only implement that. But the code should always be written following the OOPS and design principles. Now for the second type of problem statements, which I usually call the typical LLD problems, where you are basically asked to design a XYZ system. I want you to remember that writing the LLD code for the entire problem statement that is mentioned, just the way it's mentioned in the blocking course, is impossible under 50 minutes. As the LLD round is usually 1 hour long, so you have to leave room for the personal one-on-one question that happen between you and the interviewer in the end. So it suggests you to explain your solution by first stating the definition of the system and explaining its system requirements, then explain the overall components of the system by showcasing what all basically the classes and interfaces will be present along with their method. That you can write, I think, even in limited time frame. So you can do that, and then ask the interviewer into which component he wants you to dive deep, and hence implement a working solution for that component only. Rest you can explain verbally or document it inside the Google Docs or whatever you are given. In short, how I utilize my LLD rounds is like this. So particularly the first one is the problem statement clarification, which I take 2 minutes to do. Then system requirements clarification, which is 8 minutes. And then explaining all classes and their fields, interfaces, components, and basically documenting them, I take around 15 minutes. And finally, writing the code of the working solution of a particular component, I take around 20 minutes. Sometimes they want to get a working solution, or sometimes they will just be happy with the code regardless of whether it's compiling or not, depending on how much time is left. So do this, and I assure you, like, you will ace this round completely, no doubt. One pro tip that I would love to give you is that maximum chances for impressing the interviewer is in the system requirement section. As in that section, you are tested for your ability to clarify a vague problem statement, which I think is a very unique trait in any software developer, and also to provide better features for the system. So try excelling in that specific section the most, because it also tells the interviewer how well aware you are of that particular field and your profession as well. So keep that in. I'm quite sure that if you follow these steps with full dedication and determination, you can complete all of this in under 45 days, assuming that even if you are a complete amateur and are starting from scratch. So guys, I hope you liked this video. You can watch my other SD2 interview preparation videos as well that I made, like for cracking Google and Amazon interviews. I'll be coming up with more such content and preparation strategies like this. You may also comment down below and let me know regarding what all topics you want me to make a roadmap or a tutorial on. Also, don't forget to like this video so that it reaches thousands of others in need. And most importantly, please subscribe to my channel, because I'll be sharing many tips and tricks on how to improve your coding skills efficiently and crack other job interviews. Till then, stay tuned.